Hello everyone watching, my name is Raj, a student at Makerere University doing Bachelor's Computer Science at the College of Computing and Information Science. In this video, I'm going to briefly explain the history of the development of computers, and also later I'm going to also explain the evolution of Intel x86 and ARM architecture. To set the ball rolling, I'm going to talk about the history of computers, and here I'm going to start with the generation of computers, and these are the stages computers have gone through in their development. And these stages, we have the first generation, second generation, and those third generation and later generations. In the first generations, these were the idea was brought by John von Neumann and Alan Turing, who later developed them in 1945, and in 1946 they started working on their first computer, the IAS computer. Let me first talk about the characteristics of the first generations. Characteristics of the first generation computers: these ones used vacuum tubes, they produced a lot of heat, they are big in size, they produced a lot of noise while processing. To talk about the fundamental design approach, which was first implemented in the IAS computer, known as the stored program concept. This structure had the main memory, which stores both data and instructions, had the algorithmic unit, which was used for operating binary, had also the control unit, which interprets the instructions in the memory, as also input and output equipment which were operated by the control unit. To continue with the next generation, which is the second generation, here we are going to see that the vacuum tubes were replaced by the transistors, and the transistors were in solid state made of silicon. These transistors were invented by Bell Labs in 1947 and launched in 1950s. The second generation, we saw the introduction of complex arithmetic and logarithmic units, control units, and also use of high-level programming languages and the system software. And in system software, this provided the ability to load programs, even more data to peripherals, e.g. Windows and Linux. One of the computers that represents the second generation is the IBM 7094, which is a member of the second generation computers. To continue with the next generation, which is the third generation, this came up in the 1960s. Here, the integrated circuits define the third generation, and in third generations, computers used 10,000 transistors. There was also high-level programming languages like COBOL, Common Business-Oriented Language, and Fortran. The computers also increased some speed, and they are faster and more powerful compared to the second generation and the first generation computers. These computers also did multi-programming. Here what I can explain that computers could do more than 2 tasks at a time. Computers also stored on using magnetic drum. Here we are seeing the storage. Computers also improved on their output and input. An example in the third generation is the IBM 360 series, which is one of the third generation computers. Lastly, in the history of computers, we have the later generations. The later generations, these ones were classified with large-scale integration, very large-scale integration, and also ultra-large-scale integration. In very large scale integration. Here, this was achieved more. This achieved more than 10,000 components per chip, while in the ultra scale integration, here this achieved more than a billions of components per chip. In the later generations, we are going to see here computers having artificial intelligence. There are also the embedded supercomputers, and also the reduced instruction set computers as their architectures. Moving on to the next question about the evolution of ARM architecture and Intel x86. I'm going to start with ARM architecture. ARM architecture refers to the processor architecture that has evolved from RISC, which is reduced instruction set computers, design principles, and is used in embedded systems. About the evolution of ARM architecture, ARM is a family of reduced instruction computers, and these are based on microprocessors and microcontrollers designed by ARM Holdings. ARM Holdings is a company in Cambridge, England. ARM Holdings holds two types of licensable products. Those are the processors and the processor architectures. ARM architecture is widely found in smartphones and handheld devices. And here we are going to see ARM architecture was also used in the Apple's iPods and iPhone devices. ARM architecture is also virtually used in all Android devices, and as it is used as the embedded processor architecture. Talking about the origins of the ARM technology, the origins of the ARM technology can be traced back in the British-based company called the Akron Computers Company. In the early 1980s, the Akron Company was given a contract by the British Broadcasting Corporation, the BBC, and here it wanted to develop for it microarchitecture for their computer literacy project. And here, in the going through the process, the contract was successful, and the Akron got developed. The contract success enabled the Akron to go develop the first commercial RISC processor called the Akron RISC machine. Here where they got from ARM, or in short form the ARM. Here, after developing the first ARM, which is ARM1, it became operational in 1985 and was used for internal research and development, as well as the coprocessor in the BBC machine. To continue with the ARM architecture, I'm going to talk about the ARM products. ARM Holding, the company, licenses a number of specialized microprocessors and related technologies. But in bulk of the product line, they are called the Cortex family of microprocessors architecture. And here, there are three Cortex architectures, and four of them are named A, R, and M respectively. These Cortex architectures were named A, R, and M. That is Cortex A, Cortex R, and Cortex M. Moving on to the next part, which is the Intel x86. This came through in the 1970s. The Intel was based on the design of the complex instruction set computers 6. Intel incorporated the sophisticated designs and principles, and it was found mainly in the main main computers and supercomputers. More about the Intel for it, in terms of market, it was ranked number 1 because it produced microprocessors for non-embedded systems for decades. The evolution of Intel microprocessors, these started in the 1970s. I have the 1970s processors, the 1980s processors, and the 1990s processors. Up to the recent processors. In the 1970s processors examples, we have 4004, 8008, and 8086, and 8088, and these were the processors in the 1970s. Before talking about the processors in the 1970s, these were classified by the year of introduction, clock speed, bus width, and number of transistors, and feature size, and addressable memory. In the 1980s, we have many of them. Some of them we have the 384 TMDX, 386 TMXSX. To move on to the 1990s, these ones, remember, they increase, they are characterized by the speed, the bandwidth, and number of transistors. Here in the 1970s, we went on and added on the cache and the virtual memory. And the recent processors, these ones also went on and increased the clock speed, bus width, number of transistors, and feature size. Examples of the recent processors, we have the Pentium 3, Pentium 4, Core 2 Duo, and Core